Hey everybody, Adam Savage. I am here with Chris in FBFX's capture department. You guys have captured me a couple of different times with your photogrammetry rig. And I want to go to zoom out and talk about, like, this is a department where you take real things, turn them into digital things, and also where you take digital things and make them able to be real things. Is that right?
Yeah, it's the cycle of life.
But today we're talking about using this rig for something different. You got a different scanning technique to talk about.
So yeah, Gaussian Splats.
I've been hearing about Gaussian Splats for a long time.
Yeah, so that's an evolution of NRFs, neural radiance fields. So it's interesting for us because we come from a photogrammetry background where a load of cameras take pictures, build a 3D model.
And they're each taking, it's the same camera, same lens, times a couple hundred.
Times a couple of hundred. So on our big rig, we have multiple lenses, multiple cameras, because we need to get the focal length, we need to zoom in on the head, zoom in on the hand, so that's very different. But because we have the infrastructure, when Gaussian splatting came along, we could take our original data sets and throw them through software and pull out a Gaussian splat. So we were looking at our existing stuff and running it through just to see, oh, hang on a minute, it's working. So we could use our old stuff in the Gaussian splatting workflow.
So if you have a photogrammetry scan of one of your costumes, for instance, you've been able to take that scan, put it into a program, and have it turned into a Gaussian splat.
Turned into a Gaussian splat. And
what are the advantages of turning it into a Gaussian splat? What does that give you?
So, well, what is a Gaussian splat?
Let's start there.
No, so that is the question I was asking when it was coming on, because, you know, you've got a 3D model is points. So there's just points in space that are tied together as a plane, creating a polygon, and you've got a 3D model, which you can then light and shade and et cetera, et cetera. We all know that. A Gaussian splat is using points, but on this point, there is a direction, there is color, and then there is like a Gaussian distribution of transparency.
Okay.
So if you have millions of those and those interlock with each other, you get a blended image. And that can create what is perceived to be a 3D real-time asset.
A real-time asset that's at a very high resolution.
High resolution, it's lightweight.
Which, when you say lightweight, you mean in
File
terms
size.
of the computing load to turn it in real time.
Exactly. So, you know, you could have a 3 million splat Gaussian splat and a 3 million polygon asset, and one is going to run in a browser.
That's the Gaussian splat.
And one is definitely not.
It's going to cripple most home computers.
Exactly. So it's quite revolutionary in what you can now do with this data, because if you can run it in a browser, you've now got a huge area in the world where they are looking into how they can use a Gaussian splat to showcase it.
So does this help you guys, for instance, where you got a production, say, in the desert in the Middle East filming, but you need to get approval for some production piece from Los Angeles? The Gaussian splat allows you to send a much higher resolution.
I mean, that is one use case that can be used.
Right.
Because, it doesn't take us long to capture the data. It takes around 2 to 3 hours to process the data. So the same amount of time, really, for a model to a Gaussian splat.
And let's talk about that for a second. There's always post-processing. It's not like you photograph something and you have an asset.
Yeah, exactly. So with a 3D model, there is a lot of post-processing.
I would imagine, like, we have played with a bunch of your scans. You know, you guys carved me out of bead foam. You've sent us some STLs. And I'm really impressed with the post-processing on the hair work, the gentle transitions you did. And we were really clear, having looked at raw scans of me, how much work you guys did.
Yeah, there's a lot of work. It takes an artist. I mean, I'm a ZBrush artist, and, you know, so taking a scan and a ZBrush artist, they go hand in hand, because ZBrush artists use high poly data sets to be able to sculpt.
Right.
So to sculpt your hair is literally a sculpting technique. It is using the tools in the software to create pores, hair, all these other fine things that make up a human head.
And you guys have built that pipeline over the course of the company. Gaussian splats are brand new. Are you building a new pipeline for them and what they can do?
100%, definitely. So we are looking at, one, how to capture it more efficiently. So we build technology, we build our rigs, we build our capture systems. So this is not too far removed from our current capture systems to be able to optimize the splat.
Right.
But it will need building, and we're working on ways to incorporate that at the moment. So that's quite exciting.
Are there other people working in this space that you're benefiting from some of their institutional knowledge, or is it all sort of right now siloed and different folks kind of experimenting?
I think it's experimentation from different groups at the moment because no one really knows how to use it and no one knows why they want to use it.
Right.
So we've been working with a couple of, big players within the advertising industry, and they have used some of our splats within their marketing.
Yeah.
And there was obviously a lot of teething problems with that because we're experimenting, they're experimenting, but out at the end of it will come something quite amazing because the only way you move forward is to experiment,
Yes.
right? And you learn from your mistakes, you refine it, and you learn the pitfalls of it. Because like with 3D modeling or photogrammetry, there are pitfalls that if you don't do X, Y, and Z, it's going to cause problems later down the line. And some of them you can't avoid. Right, it's like if you have a beard, for example.
Yeah.
I can't get photogrammetry scanned.
No, it's
I don't
terrible.
come out very well.
Yeah.
But with splats, all this would be renderable within the scene. So there are huge advantages to Gaussian splats, but how they get used is going to be for the future to decide.
Can you walk me through some of how your computers work with them currently?
So I've got these up on the screen because these are quite interesting. So
I don't know what I'm looking at here.
No, I don't know either. But these points are essentially a Gaussian splat.
So each of these threads that I can see, it looks like I'm inside, like, I don't know, a mattress.
Yeah.
So each of these threads I can see is a Gaussian splat. What you said, a point, a trajectory, or a direction?
Yes, it's got a direction, there's a point in space, there's a direction, and there's a color with opacity. So if you imagine like a bell curve,
Yeah.
that is a Gaussian curve.
Oh,
So
right,
if you now
right.
take that bell curve and make it into 3D, you've got a concentrated point in the middle, and then it blends out,
Wow.
there, which is why you've got Gaussian blurring in Photoshop and these applications, because it's taken an average from points and
Right,
blended it.
right.
So, yeah, so this is what you're seeing, and as I zoom out of this
This is like the
and
molecular.
and I love doing this. You can see them appearing.
Yeah.
on the
No, God, I feel like we're flying out of something.
And then as you go further,
No!
further out,
Holy Go back. That was
go back
crazy.
in.
What? I don't understand.
It's pretty mad. So who'd have thought inside a Gaussian splat would be more exciting than the
true.
surface? But it is pretty crazy.
That is so fascinating. You said there's no savings here in terms of post-processing. It always takes post-processing after a
Yeah, to actually get to this point, you can run it for 2 hours, but you can run it for 10 hours and it will just get more refined and more refined and more refined because there's a thing called the steps. So it just looks at the pixel
Right.
and applies its algorithms to each Gaussian splat and refines it.
So the longer you let it go, the better it is. And then this is a lightweight, spinnable, every possible detail
Yeah, so this
there.
is like 60 FPS on this machine.
Good Lord.
And you can
You can start to read the, yeah.
So the longer I leave it and the more photos I go closer, you will be able to read that. But for now,
Wow.
like if you wanted a mid-range shot that you could add camera passes to, throw
Yeah.
it into a 3D scene. Wow. This is pretty impressive. And what's also impressive is as you rotate, you'll see that the lighting is baked in.
Oh, it's changing.
It's baked in. So this is interesting. With photogrammetry, you generally want the flatter lighting as possible. So we
Yeah.
run cross-polarized data sets. So
Right.
there's no highlights, which is perfect for a 3D model because you don't want highlights. You want to put your materials on post.
Right.
Whereas with Gaussian splats, the lighting is baked in, which means you can now light to suit your output. Wow. So if you wanted, as an example, if you had a scene where you wanted your asset in it and it was lit in a very dramatic way, rather than going photogrammetry, you could light it in that dramatic way.
Amazing.
And then you would build your Gaussian splat and it would be lit in that exact way, having all of the basically the reflections. As you can see, you can move around, there's a reflection. I don't have to apply material shader to that. It naturally has it on it. Same with all the metal surfaces.
But also, I'm even seeing how light reacts at different angles across these specular fabrics, which is like, I don't know, another way you could communicate that to an art director from, another location.
So, for our end, if we could take that and send it to a digital team, they now have a perfect reference of how this should
What
look
they-
under a certain light condition. And what's also interesting, it handles glass. I mean, photogrammetry, say goodbye to that. That is not picking that up whatsoever.
But Gaussian splats don't seem to have any problem.
It's doing something,
Yeah.
right? I mean, it's a bit janky here and there, but it's found a glass dome.
You've been immersed in the photogrammetry technology, which is, again, out at the edge, surfing at the edge of this technology. How, it seems like, even though you're not quite sure what photogrammetry is ultimately good for, it's clear it's really important, something really amazing is happening here. Is that why you're wheeling it in this early?
I think so. I was saying earlier on, I think you're going to see a lot of this in music videos. You're already seeing it in the BAFTAs. They used it on the BAFTAs to showcase the winners. But I think where this is going to come in, it's going to be all the back-end pipelines where people are going to start using it for their back-end work.
Right.
We're already seeing people. So amazingly, with Gaussian splatting works incredible with video. So if you get an iPhone, phone, camera, video camera, and you walked through this building, recorded it, you could take out every 25th frame, so every second, if you've got 25 frames, build your Gaussian splat of your walkthrough.
No.
Yeah. Then, because it's point-based, you could feed that into your 3D software. You could add a camera to your first camera. You could run the camera through all the cameras. Thus, now you've got a perfectly tracked camera shot matching your video footage.
Wow.
So you've now bypassed the idea of putting your film in to then manually track it, to track it forward, track it backward, to then plot it into 3D space. You already have it because you've built your 3D scene out of it and it looks photoreal. So that's just one thought of how this might change a pipeline within just the back-end industry.
That's amazing.
There's so much, I think, where this is going to just go into and change how people do things.
Incredible. So you also have this screen up. Tell me what's going on over here.
So because it works really well with video, drones have really good video. And because it works really well with smooth footage, drones also produce smooth footage. And I can't climb 100 foot into the air with one camera on one ladder and then move it. I wouldn't like to do that.
Yeah.
So drones are really good. So once again, we have this crazy thing that no one knows really what you're looking at until, I love doing this, so cool.
What?
You end up with that, right?
No!
So because it's taking it from a shot, you also get the background. So as I rotate around, you get parallax.
It's hard for me to even wrap my head around how
It's so cool.
good that looks.
It's so cool. So, you know, now you're thinking, okay, well, how can this be used? Well, cultural heritage. I'm sure they would love to be able to preserve a moment in time of a church, a monastery, a cathedral. Because not only that, you could do this, you could then go onto the ground, you could take photos going into the door, you can take images of all the inside, go to town photogrammetry, and now you've got a completely full walkthrough up and down, inside and out of an area.
And all this is generated from a single drone shot.
This is generated from 3 drone passes, so there'll be three or four rings.
Amazing.
And you know, if you go on set in film sets, they want stuff like this.
Right,
you want to be able to take a shot of your film set so the director can spin it around and go, well, actually, no, that's pretty good over here. If we can go zoom in here, it'd be great. Maybe we need the rigging over here. So the back end of this, to be able to build sets and to see the time of day and to see the horizon, if you need to map paint that out or add something block it, you know what I mean?
Yeah,
it's
absolutely.
pretty impressive.
No, so one of the early executions for the Boston Dynamics dog was to be a construction site chronicler, and it would just walk the construction site, basically photographing it.
LiDAR and everything.
Exactly. This does that in a fraction of the time and gets the same result.
Exactly. So it's very exciting.
Can we scan me with Gaussian splats?
I think we can.
Okay.
Let's turn you into a splat.
Let's turn me into a splat. All right, Chris, I know I stand here, but having been scanned by photogrammetry, is there anything different about doing it with a Gaussian splat?
Yeah, Gaussian splatting, you really want one camera, one lens, and just keeping it very simple.
Copy.
With a photogrammetry setup, you want to be able to capture your head close up, but your full torso. So if we had one camera, one lens,
take forever. And
we wouldn't be able to do it because you'd need to be able to zoom in on the head. So on our rig, we have dedicated set of head cameras, and they are pretty cropped in. And then we have some lower cameras that are cropped in on the feet, but then the majority of the rig is zoomed out to capture the full body or 3/4.
So for Gaussian splat, should I stop breathing while you're
No,
taking
no,
the
no,
shot
no.
or
Do
anything?
fill your boots. I mean,
Okay.
the advantage of Gaussian splatting is that you can move.
Amazing.
You can do some cool things. I really want to try fire, but not now.
Okay.
I'd like to try.
Because you know I would
Yeah,
be ready
I know.
to just jump right in.
Yeah, just capturing some fire and seeing how the fire. I mean, how will that look in 3D?
Yeah,
right?
yeah, I'm totally interested in
So
that.
I'm interested in.
When you get to that, would you send me some of that?
Yeah,
I'd
yeah.
just love to see how that looks.
Yeah, same, right? So, yeah, you can do what you want. You can
Okay.
do what you want. Okay, you ready?
Ready.
Here we go.
Oh, wow, that was fast. All right, how did that go?
Pretty good, pretty good. Very regal.
Yeah, I was doing a superhero pose.
Very regal.
This is your view. You're always looking at 200 plus shots of.
Yeah, I'm just, I scroll down just to see if there's any dropouts. Obviously, when you've got a rig that's been sort of homemade, there's the occasional black image, and
Sure.
when you get that, you can always capture again. But this is currently my favorite one of you.
I mean, not. Oh, it is midair.
Like, if we can get that built as a splat, that is going to be incredible.
I cannot wait. So these go into the program and get slowly processed.
Yeah, they do. So,
Amazing. You'll send us something to look at in the US. I cannot wait to see
The whole
this.
world will see it.
Amazing.
Amazing.
Chris, this is really exciting stuff.
It is.
I've been, my friends at Apple have been telling me about Gaussian splats for a long time and that they're important and interesting. I love seeing some real world applications.
For sure. Amazing.
Thank you, sir.
Been a pleasure.
See you next time.
Indeed.